to the Landslide Scientific Assessment Conference. It is a pleasure for me. We remember that event when we had top researchers presenting their already top published papers. One of my favorite journals, as I mentioned before, is the journal Landslide, and we are back. This year I have a wonderful opportunity. We have an excellent researcher judging with the research article that he published, and we invited all the community to be with us in this presentation. Let me welcome Gautam Prajapati. I don't know if it is the right spelling of your name. How are you?
I'm fine. How are you?
Excellent, excellent. First than anything, thank you so much for accepting this invitation.
Okay, and thank you for giving me the opportunity.
All right. Before you start with your presentation, I want to ask you, as I have done with other researchers and speakers, please tell us about yourself, maybe your affiliation, what you are doing in research right now, and you can start with your presentation. Thank you.
Okay, so thank you. And I'm Gautam Prajapati and a graduate student from Indian Institute of Technology, Roorkee. And currently under the guidance of Professor Michel Jebarda, he is from the University of Leeds, Chunil. We have developed a new method to estimate the landslide failure surface and the volume using grid points and the spline curve in Matlab. So before I will start the presentation, I will tell you why we have think about this and how it is working. There are so many landslides. In that case, what is happening means the failure has been already occurred, but the whole mass is resting over the failure surface. Means debris is not moving. In that case, it is very difficult. It is very difficult to depict or to predict the depth of failure. Means up to what depth it has been failed, and also there is no idea how to estimate the volume. And there is a risk in that case, because if the mass is resting over the failed surface, and if there is a rainy season, the rain will enter in the failed surface and it will reduce the pore pressure, and because of that the whole debris is going to flow down and it will create more hazard situation, and also the risk of the life. And also in some cases geologists visit that area to collect the borehole data, and what they do, they just make the drilling over that field surface. So there is also possibility that it will trigger the further landslide, because we are making the drilling over already the surface that has been filled. So I'm now starting how it first of all I will briefly describe how this model is working, and then we will discuss in detail. So here you can see this is the model, and can you see my slider? Means my arrow is visible or not?
Yes.
Okay. So it will need two inputs. The first is the KML file of the landslide boundary, and the second is the global DM of the study area in the TIFF format. And what will happen then, after processing some algorithm, it will finally generate the refined grid of the probable failure surface and the approximated volume. Here in this case, the user has been provided with the three options depending on the types of landslides we have. The first is the constant dip angle for the entire failure surface. And second is the varying dip and strike angle, and the interpolation will be non-linear. And the third is varying dip and strike angle, but the interpolation is linear. Now the whole model is based on the spline curve to generate the depth of failure. The spline curve required 4 parameters to generate a cubic polynomial, and from that we get the depth of failure, that is the Z value for each grid point, and we will iterate this for each grid point. So I will show you in the diagram how we are doing. Just suppose this is the landslide failure boundary. Now we have taken the grid points on this. I have chosen only few to represent. I will show you in the further slides. Now for these particular grid points, we have the cross section, and how we are going to feed the four parameters. Two will be from this side, means the left, and two will be from the right. So two are the coordinate, and the two are the first derivative. And now I will show you the application, how it is working. Here you can see this is a Katrupi landslide of the Himachal Pradesh, India, and the boundary has been traced on the Google Earth Pro, and the global DEM we can easily download from any online sources. And these are the two inputs when we are going to provide how the model is working. It will automatically select the highest and the lowest elevation point for this particular profile, and from that it will generate the steepest slope. And this slope is very important because we are going to draw the cross section perpendicular to this line. And from the DEM, it will take the grid points based on the type of resolution we have. And for ease of calculation, there will be a coordinate transformation. Now you can see for each grid point, we have generated the model will generate the cross section plane. Actually, in 3D, it is a plane, but here 2D, we are seeing the line. And for calculation of the four parameters, two for the left and two for the right, it has been further divided. In the later slide, I will explain the three methods, how we are dividing. And here in this case, for this landslide, we have used the third one. And in this case, it has been assumed that it is a part of a big circle. Now the next step is, you see, from there, it will generate the spline curve for each grid point. And on each curve, we will have one single point to get the particular Z value for the particular grid point. Now using the stem function, it will get the original Z value and the calculated Z value. Now we have the original and the calculated. From that, it will generate the 3D failure surface. Now here you can see this is the 3D failure surface, and this was the original surface, and this whole mass has been shifted. Means either has been shifted or it is resting over the failed surface. Now for calculating the volume, because when we are importing the grid data, we have also the information of the cell size of a particular grid. So we have the cell size and we have the delta Z, because we have Z original and Z calculated. So we can get the volume. For this particular landslide, it was 5.9 million meter cube. Now the advantage is data is easily available throughout the globe, and very less fieldwork is required. And failure surface and volume can be approximated in a very short duration of time. And how we can improve further, we can increase the degree of polynomial if we are having more and more data. So this was the brief intro. Now we will discuss in a more detail. So as I was saying that for this, Spline is going to play a major role for all the calculation that we are doing. So I will describe what is spline. It mathematically, a spline is described as a curve with a piecewise cubic polynomial function whose first and second derivative are continuous across the various curve sections. So here you can see we have the grid point and we have generated the cross section. Now what we will do, because for if we are generating a spline of the cubic, we will need minimum 4 parameters. And I have told you in case of the landslide, we can easily get these 4 parameters because we can easily get the coordinate from the profile. And if we are measuring the dip angle and we are projecting that dip in the direction of the particular plane, we will get the slope. Means this is the first derivative. So from here we are getting the 4 parameters, and that's all to do to generate a particular curve. And the the failure surface will lie on this particular curve. So for a particular grid, we will have a particular Z. In this way, we will generate a lot of grid and a lot of curve. So I will show you the application. For this is the first application. You know, this is the quadruple landslide, and this was the third reactivation, I think in 2017. And in the beginning, whole mass was resting over this failure surface. But because of heavy rain, when water enter into this surface, it reduces the pore pressure and the whole mass slides, and it causes a very I think it was a very dangerous. A lot of people dies. Even the transport system was blocked in that area. So you see, the boundary has been traced in the Google Earth Pro, and the model will automatically calculate these and the highest and the lowest, and it will generate the steepest slope. And from the DEM that will be downloaded from the online sources, the grid point will be generated automatically. And with the help of these grid points and the slope line, the next step is to the coordinate transformation. This is required for ease of calculation. Other because we are going to make the cross section plane perpendicular to this line, so we can rotate the coordinate for ease of calculation. And finally, from here, as I have shown you, these lines are actually plane in 3D. So for each grid point, we have the plane, and for each plane means in 2D for each line, we will need 4 parameters to generate a particular spline curve. And to get the parameter, it will be further divided in two sections. That will the right profile and the left profile. And how we are dividing, I will describe you three methods. In case of Katropi landslide, the third one was used. That was the D means it has been assumed that it is a part of a big circle. So let's discuss the three methods we are using. The first will be used, and in that case, it has been assumed that the deep angle measured is constant for the entire failure surface, and the angle formed between the cross section and the failure surface is also assumed to be constant for both the profile. And this is going to be used when we have already some geological structures like joint fault or bedding planes. If some landslide is occurring in this kind of environment, then we can use the method one. And in case of method 2, the deep and the strike angle vary from top to bottom for the left and the right profile. The weightage for the angle variation has been given based on the distance of the intersection points from the elevation line. I will show you this is the elevation line, and these are the distance of the profiles. So we know if the curvature, if it is near the elevation line, the curvature is changing quickly. But if it is far, the change in curvature is small. So the weightage for the nearest points has been given higher as compared to those which are lying away, means having more distance. And this is going to be used when the we have the profile that is the shape is either elliptical or circular or other convex shapes. Means if we are not having a elliptical or circular or any other convex shapes, then in this method it has been assumed that the left and right profile are part a big arc or circle, and then the strike and deep angle have been linearly distributed to the intersection points, making a linear interpolation. And this method can be applied if the contour limits are elliptical, circular, or other convex shapes. So here you can see from the previous slide. Now the next step was to generate the spline curve, and from the spline curves, you see we will have using the plot3 and the stem3 function in the Matlab, the pointwise z value for original and the failure surface has also been plotted to make them easier to interpret. Now you can see these circles are the original surface, means before the landslide. This will be this was like that, but this is the predicted failure surface, and these red stars are showing the depth up to which the failure has been occurred. So from here, now we have the original and the calculated. We will finally use the surface function in the MATLAB, and it will generate the 3D mesh. So this is the actual 3D failure surface. And for the volume calculation, as I have told you, because when we are importing the data from the grid, we will also have the information of the cell size. So if we are selecting a particular cell, now we have the length and width, and for height we have the original z value and the predicted or the calculated z value. So we have the delta z as a height. So if we are multiplying, we will have the volume of a particular cell, and applying the integration, we will have the total volume. So for quadruple landslide, the total approximated volume was around 5.9 million meter cube. Now I will show you the second application. This is the La Fassi landslide of the, this is in Switzerland. And again, in this case, the whole mass was resting over the failure surface. And it has a 2 km length, and the width was on an average 50 meters. And the depth was in between 60 to 100 meters. So again, it will calculate the highest and the lowest elevation point. And from the profile we have traced in the Google Earth Pro, it will finally make the slope, and for along this slope it will finally make the cross section, and finally we have the spline curves. Now here you can see these are more than 1,000 depending on the number of grid points we are providing. So higher the number of grid points, higher will be the resolution. So here you can see now for each spline curve, there lies a single grid point, and from the particular curve, we will have a particular z value. Again, in this case, you can see the blue circles are showing the original surface, and the red stars are the predicted or the calculated z values. So from this, again, you can see this is the failure surface of that particular landslide. And now the volume also has been calculated. The interesting fact is that when we were comparing this calculation with some other methods that has been already developed, we were getting a very good result. Here you can see the volume has been calculated, and it is approximately 46.4 million meter cube. Now, the calculated volume can become more adjustable by changing the deep angle for the left and the right profile. As I was saying that we were providing the four inputs in terms of the coordinate and the deep, that was the first derivative means the projection of the deep along the particular cross-section plane. So if we are changing that value, we can get the more and more accurate result. Now comparing this with the method that has been already there, this is the SLBL method, and it was giving the volume of the 49 million meter cube on the whole surface area of the landslide, which gives the active landslide volume for the most probable failure surface. And the second was the expert interpretation. They were providing the volume was around 42 million meter cube, and it will become more and more accurate by measuring the deep and strike in the field and feeding it the input data. So you can see we are calculating that is around 46.4 million meter cube, and one method it was showing 49. So we are very close to these results they are giving. Okay, now coming to the discussion and conclusion. The method aims to provide a rapid tool to estimate the depths to a surface, which can be useful for sleep surface location or and borehole planning. The assessment indicates that the using a spline calculation provide an accurate estimation of the surface depth. As I have already shown you how closer we are from the original results. But there was a problem when we were doing all these calculations. When we were making the cross section, and from that cross section, when we were counting the points, there was some cases it was possible that we were getting more than two cross section points. In that case, it is difficult to provide a particular grid point. Means we are not having the idea for which particular two pairs we will give the assign the grid. So it was fixed with the help of the some conditional operations, but it will be more better if we can assign new grid points for each set of intersection points. But I think it will be difficult. We are working on that. Now, advantage as I have already told you, data is easily available throughout the globe, and very less field work is required. We need only to measure the dip and the strike at some location, some at the top and some at the bottom. That can be easily done. And also it is risk free. There is no risks that we are going on already filled surface and we are making some drilling. That is very risky because it can trigger further landslide and even whole system can collapse. And third point is failure surface and volume can be approximated in a very short duration of time. So it's just a few minutes it will take if we are running the algorithms by providing the two inputs as I have already discussed. And we can in a very short duration of time, we can get the result. Now improvement how we can make method will become more powerful if having more parameters for the field measurement. Like the surface depth is known at a borehole location. The surface can be constrained by using an estimate of the tangent and modifying the limit used to define the spline. And if known parameters like borehole data increase, we can use 4-degree spline or higher degree instead of cubic spline to get more accurate surface. So it's all because we are depending on the spline curve. So if you want to increase the resolution, we need further data. So if we have some borehole data, then we can switch from 3-degree polynomial to 4-degree spline curve, and it will give more and more accurate result. So that's all from my side, and this was all about that. So thank you.
Wonderful, thank you. This an amazing research work. Congratulations so much, and thank you again for being here. I wish you many successes and blessings.
Yeah, same to you, and thank you for the platform. And if you have some doubt, I can. If you need, I can explain also. I have any doubt. These are some diagrams to show how it will work.
All right. Thanks. Yeah, it was a wonderful research. In fact, it is very interesting for me because we have the situation that when we prepare landslide hazard maps, when we try to define or to study as accurate as possible the landslide hazard, we usually are very good doing, or at least with what we have, very good doing physically based modeling of the spatial probability of the landslide, also probably the temporal probability of the rainfall or the event, the triggering event. But the problem with the magnitude, the volume, and even the
approximation of the volume and the propagation.
Yeah. So I consider this research is an excellent.
Yeah, it is giving the depth of failure and the estimated volume. Now we are also working on making the dynamic model. What will be the path of the movement based